In this example, we're not given the substitution that we need to use, so we're going to have to try and figure that out ourselves. So in general, you can make an integral simpler by letting u be the part inside the bracket. So here we're going to let u be x plus 1. And that's always a good starting point, if you let u be something that's inside a bracket. So you can see that that's going to make it simpler, because we're going to have, let's leave x as it is, and we can replace this with u cubed dx. Let's ignore the limits for now, we'll deal with them later on. So we want to try and make this into a u integral. So we're going to have to work out what is du by dx. So the derivative of u with respect to x is 1. So this tells us that dx is equal to du if we rearrange that. So that means we can write this integral as x u cubed, and then dx is just the same as du in this case. So we're almost done, but we've got this x here, and we want everything in terms of u. But that's not a problem, because we can rearrange our substitution to find out a formula for x. So x is equal to u minus 1. So we can replace x with u minus 1. Okay, so we need to work out this definite integral between the limits of 0 and 2. Now remember, we've got x limits, so I wouldn't recommend writing this because it's a bit weird to write x limits on a u integral, but if you wanted to, you could kind of think about it like that. So we're going to look at two different methods of doing this. One would be to use x limits. So if we're going to keep the limits as x limits, what we're going to do is we're going to ignore the limits right until the end. So all we're going to do is work out what is this integral. And then we're going to work out the integral in terms of x and then sub in the x limits. So let's expand this out. We're going to have u to the power of 4 minus u cubed du. So if we integrated that, increase the power by 1, divide by the new power, we're going to have a fifth u to the power of 5 minus a quarter u to the power of 4. And remember, we want to sub in these limits of x equals 0 and x equals 2. So we can't do that at the moment because we've got this in terms of u. So all we're going to do is go back to x. So we're going to replace u with x plus 1. So this integral is actually a fifth x plus 1 to the power of 5 minus a quarter x plus 1 to the power of 4. And now we've got our integral in terms of x, so we can sub in our limits of 0 and 2. So if we do that, let's sub in x equals 2, the top limit. So we're going to have a fifth times by 3 to the power of 5 minus a quarter times by 3 to the power of 4. And then we're going to subtract what do we get when we sub in the lower limit of 0. So we're going to have a fifth minus a quarter. And you just need to be really careful with your bracket here because we're subtracting this whole bracket here. And if you work that out, you'd get 142 over 5. The other method would be to use u limits. So if we do that, we say, well, we've got this integral in terms of u. Let's convert these limits of x equals 0 and x equals 2 into u limits. So we're going to say, well, when x equals 0, what does u equal to? So when x equals 0, u is equal to x plus 1, which is 1. And when x equals 2, u is equal to 2 plus 1, which is 3. So we know that this integral, we can replace this lower limit of x equals 0 with u equals 1. And we can replace this top limit of x equals 2 with u equals 3. And now we've got an entire integral in terms of u. So when we integrate, we're going to have the same thing that we had before, a fifth u to the power of 5 minus a quarter u to the power of 4. And this time, because we've got u limits, we can just sub these u limits straight into the integral in terms of u. So we're going to have, if we sub in the top limit, we're going to have a fifth times by 3 to the power of 5 minus a quarter times by 3 to the power of 4 minus, what do we get when we sub in the lower limit? A fifth minus a quarter. And if you work that out, you'd get the same answer that you got before.